Okay, so in this one, we've got a balloon with a mass of 1 gram, and it's filled with hydrogen gas with a density of 0.0899 kilograms per meter cubed. And the balloon has a volume of 3.20 liters, and in part A, we're asked to calculate the buoyancy force on the balloon, and we're told that the density of air surrounding the balloon is equal to 1.205 kilograms per meter cubed. Okay, so to calculate the buoyancy force, we need to remember that that is equal to the weight of the fluid or the gas it displaces. So in this case, what we're displacing is the air. So the weight of the fluid displaced is going to be the mass of air times g, and we can calculate the mass of air as it's the density of air times the volume of air times g. And now we can substitute in. We've got the density of air is 0.0899, and that's in kilograms per meter cubed. And then we've got the volume is equal to 3.20 liters. Now the problem is this is meters cubed and this is liters. So we need to take into account that there's 1,000 liters in the meter cubed. So this is meter cubed in a liter, and so that will cancel out those units for us, times g, which is 9.80 meters per second. So now we've got the units kilograms, meters per second, which is newtons, which is what we want for force. So this is equal to 0.0378 newtons, and that's an upwards force because it's a buoyancy force. Okay, now in part B, we're asked what's the net force. So to do this, let's start by drawing a diagram. So we've got a couple of forces acting on our balloon. We've got a weight force pulling it downwards, and that's going to come from the mass of the balloon itself, this rubber making up the balloon, plus it's also going to come from the mass of the H2 in the balloon. And to get it as a force, we'll need to times that by g. And then we've got the buoyancy force, which we've just calculated here, pulling it upwards. So the net force is going to be equal to the buoyancy force minus the weight force. So let's start by working out the weight force, and to do that we're going to need to know the mass, the total mass of the balloon. So we've got the 1 gram, let's do it in kilograms, so that's 1 times 10 to the minus 3 kilograms. But then we've also got the hydrogen gas inside the balloon. So the mass of hydrogen is going to be the density of the hydrogen times the volume of the balloon. So that'll be 1 times 10 to the minus 3 plus the density of hydrogen, which is 0.0899, and that's kilograms per meter cubed. So we need the volume of the balloon in meters cubed. So it's 3.20 liters. To get that liters into meters cubed, we need to divide by 1,000. So we can now solve this on the calculator to get the total mass of that hydrogen balloon. So that gives us 1.28768 times 10 to the minus 3 kilograms. And so the weight force will just be this times g, 9.8. So let's work out the net force now. So we've got the buoyancy force, which is 0.0378. And then we've got the weight force, 1.28768 times 10 to the minus 3 times 9.8. And we can solve that on the calculator. And we end up with 0.0252 newtons, and this is a net upwards force, as the buoyancy force was bigger than the weight force.